everybody. Most of you might know me. Some of you probably don't. Yes, Passive House. I've been a contractor. I've been a design build specialist. I've been a Passive House consultant, tradesman training, window development person. And as of recent, I'm now a window nerd. So yeah, fenestration consultant equal window nerd. Happy to be a window nerd. Can everybody hear me? Everything's good? All right. So, Zach, thank you, the team, Passive House Accelerator. When you guys asked us to help develop some content, I really sat down and thought like, hey, what hasn't been talked about? And really, what are the kind of questions that as window consultants on the front line of like high performance building, what kind of content can we provide the people in the community to empower them to be better at what they do, to see the future better, to assess the landscape of what's flowing at them, because it's really confusing. I've been in your position, I've been in each aspect of the process, and everyone's telling you what they're gonna sell you, but how do you know what's really out there? So I kind of put together a list of top 10 ways for you to know that you're dealing either with a high quality window or a high quality company at the best product that you can buy for your company. So I'm going to jump right in, and at the end of this, please write down the hardest question you can ask me. Try to stump me, maybe. Throw some curveballs at me. Happy to take it, whatever. And like I told the guys before, I'll make up an answer if I don't know the answer. So here we go. All right. Oh, sorry, I'm on the wrong window. All right, number 10. Let me get situated here. So one of the most important things about global windows is that not all of them are airtight. And it's really, really hard to know which one is or isn't without being like a window nerd. One of the quickest ways you can do is simply ask if they have CE testing in Europe, or if they have any Passive House in their experience. So Passive House, of course, is all about airtightness. And of course, it's the thermal and the energy performance, but it's airtightness first. So knowing that the company is an airtight window, deals with Passive House and also like can design for it is a key. And more importantly, as you're dealing with airtightness, it's something that you can't see. And so most of the time, a window company will absolutely say, hey, we're airtight. But ultimately, you don't know until the window's installed, and on a cold day, you stand in front of it and you feel it. And the truth is, we measure, or should say, high performance window companies measure their airtightness. They test for their airtightness. They work consistently in airtight buildings, and then they go and visually account for it, which is the image you see here. We regularly go and look at the buildings that we do installs for, and we see if it in fact is performing. And here you see an image of an unperforming window on the left, which is a regular double hung, next to a high performance window on the right, which is a Passive House. Number 9 is that they know each and every component of the window, and they can tell you its performance independently. From the piece of glass to the gas, to the spacer, to the gasket, to the frame, to the cladding, to every single element, they have an individual performance testing rigor for it. And the reason is because they're involved with the most high performance type of certifications there are on the market, Passive House and the others. And in order to execute those type of projects, they have to know each and every little component's performance number. That is not the case with the legacy North American windows, which is just the whole window number. A lot of times you might get a window and they're telling you, hey, the U value is excellent, it's this, it's, and the total of this, and then you're like, okay, so what's the performance of the frame? Which honestly is pretty low because it's just aluminum without a spacer. And they're like, well, we don't know. It's just, we do whole window. And I'm like, well, the glass is really high performing and the frame itself is really low performing. So overall, the total window is a good window performance, but actually in wintertime, there's condensation on the inside of the frame because it doesn't meet the standard of the region that you're in. And so when you speak to a window company, actually ask them for the performance specs for the individual components. And if they can provide that to you, then you absolutely know that they're designing a window to its top performance specs. If they can't provide that to you, You kind of got to question, kind of got to question if they know what window they actually make and if they're involved in the higher performance window market. So glass. This is one of the biggest questions we've been getting lately is do we use low iron glass? As high performance windows are becoming more and more normal, more and more people are tuning in to the fact that there's two kind of different glass production communities. There's not a lot of low iron glass being produced in North America, and that's the key to why when you buy a higher performing window, you're typically going to have to buy it from and or source it out of Europe. And it's because of the glass manufacturing in Europe produces low iron architectural glass for fenestration. There's just not a lot of it here. Why low iron? What is it? Well, one, people seek it out because of its clarity. Low iron glass has less green tone to it. That means that when you look through the window and outside world, it actually comes through in a better visual transmittance. It doesn't come across as brown glass. It has more in the white spectrum. It has a better color transmittance. It feels more natural. But a lot of people confuse low iron glass with white glass. And so there are actually a couple different categories of low iron glass. When you remove the iron from the glass, it actually does increase its clarity. But white glass, just for clarity, just for confirmation, and by the way, certain brands call it ultra clear is Guardian, or Starfire is what the Saint-Gobain out of the South America might call it. And this is glass that's used like in, say, the Apple stores for like that super white, no color whatsoever. It's a beautiful crystal looking stuff. That has an extra step where they have to further remove impurities in order for there to be no green. That's, by the way, that's very expensive glass. But when somebody uses low iron, for instance, Zola Windows, we use 100% low iron glass. And that means we're using a much higher quality glass that actually costs more to source, but it also has better UV protection, has much higher light transmittance, better solar coefficient, the color transmission's much better, but more importantly that it has to go through a more rigorous testing. And in fact, it's a higher quality glass with fewer imperfections, because during the production process, more of the glass cracks and explodes. So therefore, the imperfections are weeded out. And so you're going to get a glass to your job site that has a higher probability of not cracking on you, which is a big problem. So number 7 is the multi-point lock. This is the hardest conversation to have with people who in North America who are transitioning from the double hung and the eaves and the curtains and the window air conditioning units and the whole like community or the whole philosophy and design around double hungs, and they're transitioning to a more airtight window. The thing that I like to tell people is there's a reason they don't put sliding or double hung windows on a submarine. They just are not airtight. All you're going to do is you're going to find a hatch, and that's really what a multi-point casement or tilt turn is that it's a multiple gasket, multiple connection points, a fully adjustable. It completely ties the surrounding fixed frame to the operable sash in a way that is a long-lasting airtight connection. And more importantly, the main state of the window is closed. And so when the window's closed, the multiple connections around the window frame actually tie the frame, the operable sash to the fixed frame in a way that reduces warpage and keeps the quality of window in placement for longer. The other great thing about it is that the components are completely replaceable. It's like a Lego system. If there's ever a failure of one little piece, you just go and replace it, and you can pull it in and out and stuff like that. And that there's dozens of suppliers. It's not from one manufacturer. Of course, we use GU and Roto, and so there's so many manufacturers. So you're never stuck with one like handle. Like unlike the Marvin crank casements that I've lived with most of my life, where I'm always ordering new new stripped out cranks in order to like fix them. It seems like an ongoing problem. Multi-point hardware is also interchangeable. So you can actually take a handle off of one product line and actually put it on another product line, because they're all 42 millimeter standardized handle sets. So there's lots of aspects about multi-point, but more importantly, you're dealing with a quality window company when they are providing you, and most of their product line is multi-point windows or multi-point lift slides. The reason is because they're just higher quality, more stable, they last longer, fully adjustable. The whole ecosystem of multi-point just means everybody's happier and it's a better product. I don't know that you can do passive house or air tightness without multi-point. And that's a key thing to remember when you look at the highest performing type of windows. All right, next. This is also a complicated, well, I'll try to simplify it as much as I can. So a lot of people ask us for thermal performance. And the two things that are most important is that NFRC, North American testing and European testing are not directly, even though they're both U values, are not directly comparable. What we found is it's about an 18% difference in the testing numbers. So if I provide you with the European CE number, you actually need to discount it. You have to lower its performance number by about 18% to understand it against a North American NFRC testing number. I'll explain why in just a second. But more importantly, even though the performance is not as, it appears to be not as good for an NFRC testing, it is important that they do have CE testing in order for them to include tests that are not required in North America. That sounds really funny to say. CE testing requires airtight testing when you're in Europe. NFRC and in North America, it's voluntary. Let me say it again. It's literally NFRC. You are not required to test for airtightness in North America, but you are in Europe. And so if you're not testing for airtightness in your product lines and you're not reporting it to the customers and therefore not responsible for it, why would you go to extra steps to making airtight windows? So when you have a window company who has European testing, they have been doing that for decades. They've been required to do that. They're pushing it. They're putting them at multiple gaskets. They're using the multi-point locks. They're designing windows because they're required by testing to show that it's airtight. And the marketplace is being handed the testing certificate that says that they're either 1, 2, 3, or 4, the categories of airtightness. And when people are handed certificates in testing, they're like, no, I want 3 and 4. Why would I buy a 1 or 2 when I can buy 3 or 4? Like they actually have a mechanism. So European windows are designed to meet these criteria because they test for it. In FRC, I have actually seen testing numbers. I've seen them from the major manufacturers, but they don't report them, only for commercial where they're required, but not for residential. So it's really important to have, to know that the window company is testing to build to these higher performance type of criteria. When it comes to the U value, the key component to remember is that in FRC, testing is down to 0 degrees Fahrenheit, which is negative something Celsius. I won't go through the math. But the European testing is to 0 degrees Celsius, which is 32 degrees Fahrenheit. So when you test to 0 degrees Fahrenheit, the number for the same window is not going to look as good than if you test to 32 degrees Fahrenheit. It's going to look better. So the U values are actually tested to 2 different Fahrenheit categories. And so therefore, an NFRC U value is going to look worse than the test to the 32 degrees Fahrenheit number out of the CE, out of Europe, even though it's the same window. And so that's where the 18% differential between the two tests are. So when it comes down to it, a company that tests in both climates is going to be able to supply to you all of the nuances that you get as a positive from the European testing, plus they're going to supply to you all of the nuances that you need for the NFRC testing when it comes to U value, which is going to be the best package because you are building in the United States, so, or in North America, so it's important to have those types of tests. So you're dealing with a good window company when they can make very large units and they'll back them up. I know this is maybe obvious, but not so obvious, but regular size window units are pretty straightforward and lots of people do it. But when a company, and this is a big reason why I'm going to sell Zola here a little bit. It's a big reason why some people come to Zola is because not only do we do high performance and really good quality, but we actually can execute very large units. And the reason we can is because everything in the background is aligned. And after we make them and we put them in the field, uh, we are not scared of warranty. They're not failing on us. Some do, we fix them, but we adjust production. And we've been doing this for so long that actually we can stand behind things that other people can't make. And, and so if a company you're dealing with doesn't build their windows like the joints in the corner or use the right components or like have the right production process and quality controls and automation for the consistency of quality, they're not going to be able to execute large units. And so a window and door company who can't do large units, you should be wary about how they put their windows together, because it kind of means they might be cutting some corners, or they need to change the way the quality of their output is because they can't stand behind 10-foot tall units or large units. So it actually is a sign of what's happening in the background with a window company with the scale of what they can do. And we do get a lot of projects coming through where like, okay, yes, they said they could do it. And now that they're going to sign the contract, they can't do this tall unit. So people show up to our door and ask us if we can. And we say, yes, we can do it. We will stand behind it. And we've done it before. Here's project examples. And they're like, are you sure? Because other people say they can't do it. And we're like, nope, we got the engineering, we've got the automation, we've got the production, we've got the quality. Yes, we can do this. So, but it's a sign about what the structure is and how the company is working in the background, if they can make large units or not. We're on number 4. This is moving fast. Hopefully you guys got a lot of questions, or I can just talk slower. This is a big one. I'm a window nerd, so of course I'm partial to this. But you know, if you're not talking to the most knowledgeable people you could possibly be talking to about what you want to buy, then you're not getting the most knowledgeable information about, so you can make a decision. It's really, and I like to say the future of construction is through passive house, because that's the truth. That's where the change is taking place, and that's where the quality is, and that's where the future of energy usage. That's where the future of air quality inside, interior quality. That's where sound control is. Like, it's some of the best buildings out there. And so working with teams who are executing those buildings, that just means you're getting the best information, you're getting the frontline information. And that information, it doesn't just filter to the owner and the architecture and the design and the process and detailing. It goes to the process that your construction team is executing, and it's implementing checks and balances to know that you're actually having a construction that's airtight, and that building's going to last and be bug free and have beautiful air quality for decades to come. It's the entire ecosystem of like just quality all the way through to the process of executing. And it does. It comes from your air tightness supplier. It comes from your window supplier. It comes from your framing team. It comes from your insulation team. Like, all of those people are going to come together, and each one of them is going to have nuanced, high quality information. And through the process of interacting with them, you get it for free. I mean, it's just part of the conversation. Again, we're at Zola, the whole team, we're all building nerds, and we're just, we love sitting around talking about high performance passive house. So, and we just by chance also are just cellular windows too. So with that, it's really important that you not be the example or the test or the first or the experiment. Because if that's the case, then there are going to be failures on your dime or on your schedule. You're going to have some sort of hiccup, something's going to miss, you're going to have a reship. Through, oh my God, what year is it? I lost track of the years a few years ago. So over the last decade plus, I've do analytics on what I look at, and there are over 42 unique construction segments. So when somebody comes to my inbox or gives me a call and says, hey, I need some windows, my first job is to figure out which of the 42-ish segments they're in. Are they a skyscraper? Are they low-income UVVZ in Arizona? Are they in Alaska and they want wood and timber? Are they a huge luxury residential unit? Are they a trailer, prefab, tiny little low income? Like, is it all glass? Is it curtain wall? I mean, acoustic. There are so many segments when it comes to the type of construction and or window that they want that our first step is to figure out who you are so that we can actually recommend something to you. And that also means that maybe we don't have a window that we sell to you, or maybe you need to be talking to somebody else, or maybe we're the best fit. But if we are the fit, we have projects that we've done before that fit with what you want to do, that meet your spec, and that we have worked in your region or something similar. We may not have worked specifically in your exact neighborhood, uh, but that doesn't mean we can't build or supply to it. But we know what we can and can't do, and we'll be very honest about what does and doesn't fit. Most importantly, uh, asking the window supplier or the product supplier what specs are requested of similar projects in the past allows you to figure out if they actually have done the projects and or educate you about what you might be missing in your ask. Because one of the biggest things we could do is like a lot of times I hear people ask me questions and or look for specs on Windows, and I'm like, you know what, actually, you missed a couple. How do I know? Because the last 4 people who asked me this question asked me these 2 questions as well. So let me tell you about these 2 answers as well that you didn't ask. So the critical thing here is this last one's failing to actually vet somebody for your project type or like the exact specs when it comes to size or performance. You're probably going to find out right at the end of your design process just before ordering, and that's when you're going to have to correct this mistake. So you might be working with a company who just can't build the size you want, and then therefore didn't tell you you couldn't. And then when it came time to them actually to put their John Hancock on the contract with you, they back out or they try to get you to change your design. You don't want to be caught after months and months and months, maybe years of development in that situation. So asking the right questions up front about the project type and what they've executed for the specs you're trying to achieve, it's gonna alleviate that last minute switch out, which is always painful. So along, of course, with this top 10 and a lot of the content we produce, it's about empowering our clients to be more informed about the market. And that means sometimes selling them away, and they don't become Zola customers, but empowering somebody to do the right thing, giving them the information so that the team gets better, and empowering them to see the window market for the budget, price point, and everything that they want to do. Our goal is to sell them the right window at the right price for the budget and specs that they want. It's not to sell them any window we can. It's not to close at every deal, because a lot of times we're not the right fit, and we tell them we're not the right fit. So, but we still will give you the information, we'll educate you, we'll talk to you, because we know that you're on a path and you don't want to see dead ends. And when you might have a project, you come back around. But either way, we're here to help support liaison. That's why we support House Accelerator. That's why we're involved Zola. Like, we're the building nerds. We're about change. We're change agents. They're selling high quality product. And our goal is to empower your team to be that as well. And then most importantly, all of the above doesn't cost more. Just because it's higher quality doesn't mean it's going to cost twice or 3x. Just because it's using the better glass and more gasket doesn't mean it's more expensive. What really is happening in North America is that poor performing windows and doors actually cost too much. So when you compare those poor performing windows and doors to what we now can provide you, high performance, that's competitive, that's component based, that's switchable, with a marketplace that has dozens of different hardware and multiple glass suppliers and frames from 1,000 different sources, we can actually put them together in very, very high performance, reasonable ways that are cost competitive or cheaper than what you might get for a window that's a third or half the performance, not airtight on the North American market. And that's at the core of like the entire dynamic of what's switching over, is that the manufacturing capabilities of Europe and the competitive market of the European support, as well as the educational institutions and investment in technology, in high performance buildings. And I'll just throw out in the current climate, as a result of energy dependence on people who may not be reliable in supplying your gas during the winter, like what's happening in the war in Ukraine. that European countries have a security and defense mechanism to be less reliant on heating and supply of gas from Soviet Union and Russia. So that key component meant for the last 3 or 4 decades, the European Union has been developing high performance construction in a marketplace to be more competitive so that it's ubiquitous everywhere. And that's been done in the glass, that's been done in the hardware, that's been done in the gaskets, the frames, the designs, the extrusions, everything. And so there's been competitive marketplace over the last 30 years on that. And now it's that those high performance windows out of Europe don't cost more when you bring them into the United States. And so that's a key, is that we're utilizing the best of what's in the world. We're utilizing the highest performance we can get. We're providing all the right specs, all the right testing. We're bringing it to North America. We're bringing all the knowledge of the North American projects in the marketplaces. We're identifying what they would have been doing and fitting it with what's new. And we're doing it at a price that is absolutely competitive or on par and often cheaper than what you would expect. So that's a top 10. I'm going to leave it there. I probably could talk 3 times longer, but I'll just keep this short and send it back to Zach. Thanks, guys.
Great, awesome, Sam, fantastic. And we do have quite a few questions queued up here. I thought maybe we could start though by if you wouldn't mind, just doing a quick overview. There are 4 different frame types, I think, that Zola currently offers, and a 5th coming. Would you mind just doing a brief kind of survey of that?
Yeah, and I'll actually structure it in budget and cost and performance as well. So a lot of people will come in and say, well, what's the price difference between UPVC? And I'll describe what UPVC is in a second compared to vinyl. What's the cost difference between UPVC, all wood, aluminum clad wood, and all aluminum? And the 5th one that Zach was alluding to is steel. And the way in which I list them, UPVC, wood, aluminum clad wood, aluminum, and steel, is in fact the budgetary. UPVC is the cheapest, steel is the most expensive. The frame differential is that, the differences in the frame is that softer materials are better insulators, but are worse at structure. So you can have really thin steel windows, but they're really poor thermal performance because they're really dense and heavy and thin. You can have really high performance UPVC windows, but the frames have to be big and bulky because the material is soft. Wood is the kind of the transition. So if you think about actually the thermal performance of the actual material and then the balance with the structure, the kind of the funny thing is with aluminum, if it's all aluminum, it has no insulation. So they insert insulation into the core and then the aluminum's on the outside. And my joke is, at what point does a thermally broken aluminum frame become a aluminum clad plastic frame? Where's the break transition between an aluminum frame actually turning into a plastic UPVC type frame with a clad on the outside? So we carry UPVC at the cheapest, and then we do all wood, which is the landmarks and other stuff as well. I actually see a lot of people transitioning into the all wood frames because of the change in cost in the marketplace. As there has been an escalation in price over the last 2 years because of all things related to the global nightmare we're going through. And a lot of windows were preferred to be aluminum clad. People wanted to do aluminum clad, but aluminum has seen a skyrocket in costs. And so more people are actually looking at all wood because the actual finish coatings on the all wood product are super high quality. These are not hand painted windows. These are industrial spec finished windows with a decade and a half long finish warranty on it or so. Like, they really do last a long time. So those type of windows, so you get the price differentials. And just so you know, UPVC is, if it were one, a wood clad would be 2x. And a steel, maybe 2.5 to 3x the UPVC. And that's for the same square footage, just to give you an idea of budget. And the UPVC would be the highest performance at the lowest price, which is the global kind of, like, I like to call the Volkswagen of windows. If you need a window, buy UPVC. It's huge and high performance and the right price. And then, of course, the wood and the aluminum. Whenever you add aluminum and metal, that's when the price skyrockets. So, is that good, Zach?
Yes, thank you. That's
All right.
great, Sam. Thank you. I just want to note, Peter and Chris, you both have your hands up. It looks like on Zoom. If you have a question, please type it in chat, and I'll get you into the queue. Just wanted to note that. So, speaking of the queue, first up is Trevor Harris. Trevor, are you here and able to ask your question?
Yeah, hi. I was recently had my hands on a couple of window samples at a main building show, and it occurred to me when I was looking at them that the gaskets are different materials. In this case, between a Schuko and a Salamander, and the I'm just thinking that the type of gasket, because the air integrity is so important, may fail first. And I'm just trying to think about what you know about the gasket materials on that are available, and the longevity, and actually their ability to seal, to mate at the corners, and mate at the window, and where they're being placed into the window frame.
Yeah, absolutely. So yeah, it's about I want to call it freeze thaw. It's not that extreme, but it's about temperature differentials. The gasket changing its dimension and actually elongating and contracting with temperature change, and as well as embrittlement, which means over the long term, a gasket remains squishy and compressive and doesn't get hardened. The best material is EPDM. That's the go-to. That's the one that's used in airline industry. That's the one that used in the auto industry. There's a lot of crossover between the testing when it comes to aeronautics, space industry, and also auto industry into the window market, and making sure you have an EPDM gasket that actually has glued corners. So when it does move, it doesn't pull away from those key components, which is the transition. The other way that they might do a corner is, instead of actually fully slicing the gasket and just letting them slip together, but they actually just cut a little V, and the outside is a bend. And so looking at the construction of the corners and seeing that it's a bend and it's actually one piece with just a little notch, so it makes the 90, and that it's EPDM, is the standard for a good install. The last thing is that you do not want the gasket, when it encircles the window, you don't want it to end in a corner. You want the actual seam to end in the middle, because most of the movement is going to recompress back to the middle. It's going to pull away from the corners. So does that help you, Trevor?
Yes, thank you.
Yeah, sure. Okay.
Great, thank you, Trevor. Okay, next up is Nancy Fleming. So
TikTok.
Yeah.
Okay, we'll come back.
So her question is, how does Zola manage installation and warranty coverage for homes outside of Colorado?
All right, so I don't do any projects in Colorado personally. I'm New York, LA, San Francisco, everywhere else. So we're all across the country. Part of what we do is we train and or support anyone who wants to install a window. The key component with like any European window, especially Zola, is that often is the case that when we give you the window, the structure of the window is so robust that it often is much more structural than the 2x4 opening that you're sticking it into. We're not a window where you need to put a little shim and screw it, and actually you need the 2x4 next to the window in order to stabilize the structure. Our windows are self-structured. That's what the multi-point, that's what the whole steel reinforcement, that's what's going on. And so we actually train all of our customers to become European window installers, which means they know how to inspect, they know how to see. Now, of course, we can send in installers, and we actually have training specialists who fly all over the country and can come to your project and either inspect what you've done, support a problem that has happened, or train your team to become that. But once you see how easy these windows go in, there's like a clip or a through screw, and you just support it, and it's self-balancing, and the entire process. It is so much easier to install a European window than it is to install most American windows, most North American windows.
Great, thank you. Okay, so next up is Daniel Clark. Daniel, can you unmute yourself and ask your question?
Yeah, hey man, I'm gonna get a twofer here. First question is there was one slide that has those floor to ceiling sliding glass doors. Just wanted to check if you guys actually manufacture Passive House certified version of those. Shoot, and I forgot my, do your warranties cover the windows regardless of the color? Because I mean, if you're comparing a white frame versus a black frame that undergoes a lot of thermal stress, that puts a lot of stress on the gaskets and the frame too. So does your warranty still cover that?
So first one was large units. Sorry, repeat the first question.
Yeah, large sliding glass.
So we regularly do 8 foot by 10 foot. We work from 8 foot by 10 foot pieces of glass. We regularly build those daily and ship them. And were you asking about the warranty on the loan? Sorry, I really can't remember the first question because I'm still thinking about the multicolor UPVC black.
Yeah, the large units, just to, if you have Passive House certified versions.
Passive House certified. Oh yes, good. This is important. So there are two levels. When you say Passive House certified, that might mean that the actual door is in the Passive House database as a certified component. But hopefully most of you know that that is not required to build a Passive House. So there are Passive House appropriate products that are not necessarily pre-certified as a component that actually are used, and that is how most passive houses are built, is actually they used high performance products that are appropriate for the region that are not necessarily certified in and of themselves. Those products are actually a little bit lower performance than what is typically needed for a true certified passive house component. So there's two approaches. There's the component certified approach, and then there's the whole house holistic approach model. We do not have a passive house certified lift slide in the database. We do have our windows, but we don't have a lift slide. We do have a lift slide triple glazed that has gasketing that is adjusted and corrected and appropriate for high performance passive house and large slides. Not all lift slides on the market are airtight enough to meet the blower door, especially for smaller houses. We do have a wood, an aluminum clad system for our lift slides that actually does get regularly used. And I'll just throw out that accordion or nanotype walls, the whole ones, none of those are appropriate for passive house because there's too many gasket connections, and I'm not sure anybody could get airtightness with one of those. So dark warranty, large frames, UPVC moves the most. So when you put a black foil on a UPVC, we reduce the sizes that you're allowed to do. We just can't do lengths above certain sizes because of that expansion and contraction. With the rest of the components and the frames, the wood, the claddings, the aluminum, no, our warranty stands. So if we will make it for you, the warranty will come with it, and we're upfront about that. A lot of people ask us to make stuff that we won't carry a warranty on. We do that in fewer and fewer cases. Sometimes we will make a unit that we won't warranty, and we'll be very clear upfront that it's not going to have a warranty with it because of the way in which you're asking for it. For example, you don't want it fully finished because you want to do something to the interior face of the wood. Sometimes we do that, but honestly, we can't warranty it because we didn't give it to you fully finished. So anyway, does that answer? It's good.
Excellent. All right. So up next, this isn't really a question, but it's an interesting information from Drake Chan. Drake, do you want to come on and share that?
Sure. Can anybody hear me?
Yep.
All right, cool. Hello. Hey, Sam. Good to see you again.
Okay.
Hey. Yeah, I just wanted to point out, you mentioned that NFRC, yes, they do not test for air tightness, but we Windows over here and in Canada, they do the AMA, AMA, and NAFS testing, which is like for air tightness. It's also for structural. Their sample,
water tightness as well. Yeah.
Yeah, and water tightness, all sorts of things. There's also even break-in and all that. And yeah, it's also like their window sizes are depending on the class. Like AW classes could be like humongous, like the test sample windows. Yeah.
So AMA is mostly a commercial spec. So in the residential realm, AMA is not even asked for. NFRC is the lay of the land. So yes, on the commercial end of it, there's way more testing, way more requirements. Yeah.
Yeah. And actually, I have a follow-up question because this is just because we have local law 97 here. I'm sure, like my building, it's a 500-foot condo. It's gonna have it's all the building's 25 years old. The windows are all non-thermally broken, so and they're all very leaky. So we have to replace them. They're past their lifespan. For like these tall, buildings, it's well, what do you suggest in terms of materials, versus, keeping the same energy efficiency in order to withstand a wind?
Yeah, it also depends on, there's a little bit more nuance, the building type and do people have window air conditionings?
No, this is, yeah,
Yeah,
not this case.
there's a lot of nuances to actually the mechanical infrastructure that's going on in the building. What we see is it's either UPVC or aluminum tilt turns.
Mhm.
And the key is, you're New York City local law 97. So the key is going to be that if it's DOH child falls requirements, if that
Yeah.
falls under the purview, then all of a sudden you cannot do tilt. You can only do turn with a turn limiter.
So
The
they don't
reason
even,
being the tilt arm fails the DOH test.
okay, so they don't even allow the ball test to do that.
Well, it's not even the ball test. It's about like 150-pound pull test. And
The ball test, yeah.
Yeah, the pull.
The hardware is just not.
So it has to have
hardware.
an additional swing limiter in the turn that actually can take that test, but
I
there
see.
is none for the tilt. So the tilt
Yeah.
is out. So you're going to do turn only, probably aluminum. Depends on the project type. A lot of people are talking to us about UPVC as well. So
Okay, so just one or the other, but not tilt and turn.
well, again, DOH purview. If you have the Department of Health child falls
Yeah.
requirement, that test takes out the tilt.
Okay, sure. All right, great. Thank you.
Okay, sure.
All right, great, thank you. So Ryan, got your message. Ryan had a chicken or the egg question, so we'll skip over to Martin Volker. Let's see. Actually, I think that maybe Martin. Yeah, he said he wasn't able to ask it in person, so I'll convey it. Can you speak to current lead times given shipping from Europe?
Yes.
You probably hear this question frequently.
It's really important, and I'll even talk
Yeah.
to the dynamic to what to watch out for to see what changes are taking place. So, yeah, we're 20 weeks right now to New York City, and that's production start, production shipping to city. We were 14 to 16 weeks. Maybe for UPVC would be 12 weeks prior to all this. There may be an additional week in production or a week and a half in production on our end because of like the whole container situation with getting materials and moving stuff around. But most of that change is actually because of port side US and containers just sitting in a ship offshore, and then the slow offload, and then the trucking situation in the United States or North America. I don't know so much about outside of the US and North America, but definitely the ports in the United States are really just chugging along and just handcuffed the entire economy. So it's 20 weeks right now. So if you're watching the news and you see, hey, you know what, they fixed the port situations and things are moving faster, then you're going to see those benefits. That's literally going to be, if you see the news and they're like, that they're not shipping empty containers away without having stuff and it's actually gotten back to normal, that's when you're going to see those numbers come down. So it is literally, it's 20 weeks. We might see a 21 week because we couldn't get a container or there wasn't a berth on a ship and therefore couldn't fit it. And so it added a week, but it's right in that range for the East Coast. West Coast, at about a week and a half or 2 weeks sometimes, maybe 22 weeks, 21 weeks. So.
Excellent, thank you. Okay, up next is Jim Campbell.
Hi, Sam. Thanks for your presentation. And we're in Ontario, Canada. And so my question was about getting the product here, which Thomas responded in the chat, so I can reach out there. But I'm just curious, yeah, when, like you're saying, you train whether it's the contractor or whoever, but it's just when something goes wrong, which maybe ideally doesn't happen, but sometimes does. How is that addressed? Like, is Zola compensating that contractor to deal with the problem that otherwise, I take it that there's no tech reps being sent out from headquarters in North America to deal with?
We have tech reps that fly, and that's what their job is, to go to the job sites,
Okay.
either through a paid visit to train and or support ahead of time, or to rectify a warranty issue and deal with something that might be a production flaw. Or, they need support changing out glass, but we're constantly shipping hardware components, pieces, handles, replacement glass all over the place. We're just like a modern company where it's just like flowing like Amazon. So we support 100% no matter what the situation. So if something goes wrong, and that something could be massive or minor, we're 100% supporting the best resolution in the fastest time to get it done.
Right.
We're definitely not going to hold you hostage to say, don't touch it. It's sitting there. We'll have somebody there in 3 months. We don't do that. Like if the best route is to get you on a Zoom call and to support your team, to show you how the component gets switched out and this and that, then we empower you to do that. And honestly, when it comes down to it, the window and doors are actually really straightforward. It is rocket science in the design, but it's not rocket science in the way it's put together. It is still just screws and hex nuts and stuff like that. It's not highly complicated. It's just knowing the nuances of it, and we provide that information to empower the faster resolution for all the problems when there's a
Right.
problem.
So that question about for Ontario, like again, Thomas contacted, but do you have a distributor set up, or how does it work?
I don't deal with Canada, and I'm not sure Zola sells to Canada right now, and I don't know why we don't. So I apologize for not having the exact answer, because I am fully entrenched in San Francisco, LA, and New York City. But I don't know that we are actually currently selling to Canada, and I'm not sure why we aren't. So I apologize for not having that answer. If you could contact through the website our project point and see what that answer is, and then email me. No, I'll go find out after I get off this if we are going to or not. But for some reason, the two business holding two companies and having to start Zola Canada and this and that, I don't think we have that going. So
Okay, thank you.
sure.
All right, thank you. Jeff Betts, you're up next.
Hey Jeff, you're on mute. There you go.
Hey Sam, I have more of a, so we do installations, and you guys know us.
Yeah, how you been?
Pretty good. It's interesting your point on shipping and your lead times, because it's pretty impressive. Because I wanted to add to one of the critical things on like shipping right now is, while there's a platform where people listening, is like, one, I think transparency is a big part of it, because there are, like, we've installed for a numerous number of importers, and like, ask for the pro forma invoices. I would say to everyone, ask to see what they're paying for shipping. There's no reason that can't be open, and I wouldn't really get upset if a window supplier tries to tell you that, the shipping rates have gone up. It's no one's fault. It's just happening, and you can avoid a lot by having kind of an upfront agreement with involved in shipping. If you try to nickel and dime someone on shipping, like, it's just going to cause problems, and it's essentially going to sabotage the project from the inside. And one way to like look at shipping things, like, you guys, I imagine you guys are constantly ordering containers on a rotating basis and then filling them, because it's the only way you can get lead times like that. Because like, I'm looking at 2 projects right now where I have the pro forma, I have everything in front of me right now, and it's 10-week shipping time. So ships are actually going back, they're reserving a ship, it's leaving, going to the US, coming back, and then going with the windows. So it's painful, because you watch it, you're like, why can't my container fit on there? Yeah. Another one I watched go all the way to North Korea, back through the Suez Canal, and now it's coming to the US. And like, that's just the reality of things. So if you're getting anything less than 30 weeks, that's one thing that's nice about Zola, I think, is because of the buying power, you can continuously have containers going. Because if you go someone that's smaller, the reality is it's going to take longer.
Yeah, we're pre-booking the berths before we even know what project's going to take it. That's a good thing.
And that's the only way to really counter it right now. And I think that's why it's important, if you hear lead times from people that are extreme, like, that's a big part of it, is the shipping containers. Like, a lot of people are booking stuff like, when the order comes in, versus 3 years ago, you could book a container a week before you knew it was done in the factory. And I think another part with that is the reason I say look at the pro forma invoices is because like now everyone can do their business how they want, but in the end, if someone is raising the shipping rates, you want to know like that it's actually real. And I've been in between a number of manufacturers and clients where this has happened, and it gets hairy. So I think that's tough.
Let me explain. Like, there's actually an inference there that actually that the shipping cost is slippery and can be changed. We actually don't do that. We hold a fixed shipping rate. Right now, it's $7,800 to anywhere in North America or anywhere in the United States.
Yeah,
that's not the true cost of shipping. The
Right.
actual flexibility is that we've been seeing costs somewhere between $9,000 to $10,000 to up to $19,000 for each container.
Yeah.
But that's as part of the window contract. We absorb that as part of the actual cost of the project. But what that means is like if it's on the proposal and it says 7,800 and you sign it, it's 7,800. There's no flexibility. We never change that.
And that's what I mean. Like, watch out for people that call clients, ask them how shipping was handled. If I could give advice to any homeowners, builders, or architects just getting into this, it would be shipping is something you really want to have a precedent for. You want to have an upfront agreement. You want to have a contract for, and it's just like, I think what you're doing is great like that. I think that's, I've seen companies, some sharing the cost and doing exactly what you're describing, and others, the project arrives and all of a sudden it's before you get your windows, you're getting told it's $5,000 more, and it's a nightmare.
And we also often get the questions like, well, is there any additional cost for like customs and all that stuff? No, this is literally factored into your site. The cost that we just gave you is literally, it's going to the containers showing up to your site. So there's no additional cost. That's it. So.
Yeah, that's we went to a delivery this morning. It's not coming from overseas. It's European windows, and they're being made here. And we were told this morning the truck isn't showing up. So like it's not just it's not just a European thing either.
Yeah. Awesome. Good feedback. Thanks, Jeff.
Thanks, Jeff. Okay, next up is Ted Landrum.
Hi. First of all, thanks. Excellent presentation, and congratulations on being involved with a very high quality product and being ahead of the curve in terms of Passive House and all of that. The questions, I'm also in Canada, so there's some disappointment about needing products that deal with more extreme climate. So my question is for—
Why don't everybody who's from Canada on this podcast, why don't you just send an email through the Zola website and ask the question, do you ship? And just do it in mass today, and then they'll be like, why did they—
No, it's okay. Look, I mean, everybody on here knows about global warming, and things are getting a lot worse faster. So a lot of promises are being made about reducing carbon footprint. I posted in there that the city of Vancouver has just voted, I think yesterday, to require all new buildings do embodied carbon reporting and limitations. So no one's going to be able to specify the products if we don't have the carbon footprint as well as the energy performance by component, So the ultra clear glass takes a lot more energy to manufacture and to ship. So we need to know, maybe we should compromise a little bit on the clarity of the glass and other things like that. But so that's my question is, what is your company, what is Zola doing to be even better? What are the next steps? Are there alternative frame materials you're looking at? Do you do 4-quad? I don't know what. Maybe you could just tell us what you're planning to improve the product to deal with the extremes of 50 degrees plus Celsius temperatures. We get 40.
We are just completing the renovation of McMurdo Station in Antarctica. So those are now Zola windows, which is, I think, -60 is the design low temp, which is extreme. That is even more so than 4-quad. It might even be bigger. I don't know. Florian, the boss guy, he's the one who directly dealt with that. So true window nerds when it comes to like extreme, it was a custom frame. Unfortunately, because of distribution issues, we actually had to drop the quad pane glass for now. The other thing we had to do is we don't have a source for Krypton. And you can blame SpaceX because that's the propellant they're using in their little stupid satellite internet systems, Krypton, for adjusting their satellites, and they bought up the Krypton market. So we can't actually buy Krypton for our windows. So we are triple Argon Max right now. Okay. The other thing is I think when it comes to embodied energy, yes, glass is heavy, you know, when it comes to the amount of energy it takes. But I think people need to recognize that aluminum is extremely high amounts of energy. So whenever you ask for aluminum clad window, you are adding tons of carbon footprint production. When you're asking for an all aluminum window, it's a pretty high. The lowest carbon footprint production is actually UPVC, believe it or not. And there's a bunch of reports out of Europe that it has the highest performance frame at the lowest embodied energy footprint. Like, it's just so much a balance. But people, of course, plastic, but it also is a single source plastic. It's not mixed most of the time. So it's highly recyclable, and it can be also highly recycled. So in Europe, they're coming up with these new frames that are just using waste plastic, UPVC thermal waste plastic from previous construction, to like keep putting it back into the system. And those windows have an even lower embodied energy while providing decades of high performance multi-point, you know. Of course, Canada has lots of trees. They have lots of timber. Those are always going to be, you know, carbon sequestering. The best kind of source is to use what you have locally, you know what I mean? Not to buy international, you know, reduce the distance in the footprint. But, you know, of course, the glass needs to come from somewhere, and who can produce glass except for big glass factories? And there's not a lot of those in North America. So it's a bit of a conundrum, because, you know, there's a glass map. I don't know what the URL is. There's a company that tracks it all. I actually found the output of 2 factories in Eastern China. Out of the hundreds of factories, 2 factories in Northeast China produced more glass than all glass output east of the Mississippi in the United States. There is no glass manufacturing in the United States when you actually look at it at a global scale. It's such a tiny amount. It's all in Eastern Europe and China and elsewhere. So that's a huge problem. So yes, embodied energy, but distance to the site from the source, and also the type of frame when it comes to performance. I actually think, for my own personal house, I would buy fiberglass, not steel reinforced, but fiberglass reinforced UPVC. And I would make sure that it was recycled after it was used, after 30 years lifespan or whatever it's going to go through, you know. And I know it's plastic, but when it comes to actually dealing with the oil industry that we have and the amount of, I mean, it is literally a natural resource right now that's just like bleeding through our economy. So when it comes to actual carbon footprint upfront, and then of course for the rest of the house, I'd use as much reused material, found material, raw material in ways that are unprocessed as possible, you know. So
Excellent, thank you.
sure.
Great, thanks, Ted. Michael Lind, you're up. Michael, I see you on the call there. Are you able to unmute yourself and ask your question? If not, I will do it. I'll ask it for you. Okay, so Michael's question is, how important is low CHGC in Texas when window is well shaded from direct sun exposure and looks out toward trees?
Solar heat gain coefficient, and by the way, I'm a passive house person, so modeling the actual install for its conditions is the true SHGC, not just the window itself. So if it's in a shade condition with an overhang, then you have excellent install conditions and it's in its perfect state. If it's, you know, if you don't have to worry about 90 degrees during winter sun, because low sun in Texas is also a problem because it gets up to 90 in December. So it has to do with the installed as is. Like, is that tree going to stay with its leaves all year round? Is it going to be the shade that you need all year round? And then how much air conditioning load are you using to offset it? And in some places, depends on the altitude. It might be super hot, but then also it might get cool and you might need that sun. So again, I'm a proponent of the actual true in situ passive house modeling, where you can actually do that annual modeling and get a feel for each and every window on your building, and if it does in fact what the SHGC should be. Also, maybe it's time that we bring in the European model of actually having exterior shutters, which lets you choose the SHGC of your window by raising or lowering and doing that. It's just not part of the design process in the North American, but it is so smart that Europeans have been doing that for centuries. So.
Okay, awesome. Okay, so next is Nitin Mehta. Nitin, are you here?
My question would be, Sam, it's a great presentation. I enjoyed so far. What would be the maximum size, width, and height of a fixed window that you supply?
Our standard glass size before we kick over into overcharge, we'll do an 8 foot by 10 foot triple in almost any frame type. So that's either 10 foot tall or 8 foot wide. The next price or deciding factor is the height of the container. Typically, it's about a 7/8 is like what can fit in without having to turn, or really close to it without having to turn over. We can do oversized, I don't know, up to 30 foot. So 7/8 by 30 foot. And at that point, then you have to go to an open top container, which adds additional costs. And then, of course, I don't even know how you're going to lift any of those because they're about 8.5 pounds a square foot. So good luck getting them out anyway. They're huge.
So
But they can go very big.
So would 10 feet or 12 feet length be okay if it is 4 feet high?
No problem. 4 by 10 is standard cost. 4 by
Okay.
12, 4 by 12 would be oversized because you did break either 8 foot or 10 foot, and that would have to come from a specialty glass. It's bigger.
So 4 by 10 is standard.
8 foot by 10 foot is standard.
Okay. Thank you.
Yeah. If it fits within that piece, then it's standard glass size. And I do want to point out that maybe I've historically pre-COVID had gone to European trade shows, as I see a couple. I see Patrick on here. Hey, Patrick, what's up? Go to European trade shows, and I've seen units that are 12.5 foot wide by 27 foot tall French opening sliders, single piece of glass. They have massive production capability and engineering in Europe. We can't fit it in a container. They have it, we can't ship it. I just want you to know, I've seen a triple glazed, uniglass at a triple glazed piece of glass at Bau Munich, and it was 56.5 feet long by 18 foot tall triple. It was a massive piece of glass. I don't even know how they got it there. There's not even a train that could carry it there. It's just so huge. So they're just showing off, and this is what they can do, and all we can do is fit it in a container and ship it to you. So.
Mhm. Okay, thanks.
Sure.
Thanks, Nitin. Okay, Sasha, you're up next.
Hello. I mean, I think I addressed the question already, and I think I may know the answer for the unpresence of Zola systems in Canada. Maybe it comes to that infiltration difference in ZNFs. I think one of the people, I think Jeff, posted the NAFS, North American Fenestration Standards. There's a big difference between infiltration, actually exfiltration of that is not been tested in United States, as far as I understand from a quick read.
Big
Yeah.
kudos to Canada for being a higher standard than the US. Yeah.
Yes. So, and I maybe that's the reason. So, I mean, I just wanted to know if, because I was looking recently dealing on a project requiring really high performance windows, but also high-end client for residential purposes, and I couldn't find many options.
No, there's not a lot. Yeah.
Yeah, and I wish to have a more local, and you guys discussed that as well, a more local options so that you can actually manufacture. You don't ship it from either Europe or even further from China. So
there were a couple manufacturers who tried to develop European windows up in the Massachusetts area. There's one a long time ago, within the last decade, and they were importing everything. And in fact, Marvin did create a Passive House certified window, but the truth is, both of them came to market, and the prices were so high that they couldn't compete, and nobody bought them.
yeah, well, we have Lowen's here as well, Lowen, but their prices are also very, very high. Out of Regina, I believe.
Mm-hmm. So it's a nuanced aspect of like raw material cost, manufacturing cost, how many robots they have. I mean, the standard for our factory is robotic. Like a UPVC window is hardly touched by a human. It's cut, it's adhered. It's like literally there's hardware placement robots putting the components on. Like they can produce 600 units with 2 guys a day or some sessions. It's like some crazy numbers. It's pretty impressive to watch. That's not how North America runs their window production.
Thank you.
Mm-hmm.
Great, and yeah, and thanks for bringing up NAFs. I mean, my understanding is that NAFs, it applies both on the U.S. and the Canadian side, but that it's more rigorous in Canada. Is that right?
I believe so. That's from what I understand.
Yeah.
And it's been a while, for I think since 2012 they integrated this into a building code in Ontario, but also in BC, and I think it's majority of the Canada now.
Right. So there's as kind of a supplement to NFRC. So there is a mechanism for looking at airtightness.
Yep.
Cool. Okay. So Jeff, I see your hand up, but I also want to make sure we get to these folks who've been waiting patiently. So we'll circle back. Okay. So next up is Kevin Ellingson. Kevin, are you still on the call? Kind of. No, Kevin's not here. So Juanita Elias, are you here?
I'm here.
Okay, great.
And anybody who has a robotic factory, I love them. It's the only way to go. So my questions were about wood windows.
Yeah.
And two issues is once you start going with a triple pane, the joinery has to be really beefy. The frame has to be beefy. So what are the dimensions of those? What kind of joinery that would support that, and so that the glass doesn't distort the frame, sort of thing. So
Furniture grade
then
connections.
what is the species of wood?
So furniture grade connections, not doweled corners. They actually need to be lapped and finished. The wood needs to be pre-stabilized on all sides before the connection's made, so it doesn't warp and change. And it does need to be beefy in order for it not to have that rack and the ability to change. But there are certain ways to get around that may or may not make it easy to service the window. And we don't do this, but you can structurally glaze the glass to the frame, which connects the connection of the glass to the, but if the glass breaks, then you've got to damage.
Right.
You got to damage the frame to get the glass
not
out. Or something. So there's like a combination of factors. Our favorite wood, my favorite wood, is finger joined conifer. We call it finger joined pine. It's an engineered timber, which means it's the best part of smaller species and shorter pieces that are stabilized with all the grains in the right directions. It's just engineered timber, just like everybody's using for structural construction and all that kind of stuff at a higher quality. So it's furniture grade engineered finger joined pine is what I prefer. But we can do, of course, straight grain and all the other stuff. And
Okay.
I want to say that the furniture grade oak market is extremely expensive right now. I would not recommend the additional 30+% that it costs to do oak. And that larch is a Russian forest, so don't be buying larch right now because it comes out of Russia. So everybody should have dropped it. So.
Well, larch doesn't weather well in the northern climates in the United States and Canada.
Yeah.
So it's basically finger jointed. And so you have a very, very, very sturdy adhesive that you use, right?
Yeah, just like the rest of the timber market, the way it's put
Okay.
together, the way it's reversed, the way it's jointed, the way it's all the grains. So it's the best parts all, and that's why we can do very large units, is also
Yeah.
because we have very good structural timber that we start from. If we used solid timber, you would start to see warping as it tried to flail off into its
Right.
direction, but we use an engineered timber, so we can actually do those.
Okay, that sounds good. Thanks.
Sure.
Thanks, Juanita. Okay, up next is Gary Klein.
Hey, Gary.
Hello, everyone. Sorry I wasn't able to attend the webinar itself. I got stuck on other meetings, but that never happens to anyone on this call, right?
No.
So the question I asked was put in the chat. You were mentioning, Sam, about using various UVB plastics and other such things. And I've had vinyl windows now since 1989 on new homes here in California. And so far, the frames are holding up fine in fairly large amounts of solar gain. Even the west walls get lots and lots of afternoon sun for many hours. And we have stucco. So I worry about all these connections long term. I'm certain that plastics bake in the sun and heat. I don't care what anybody tells me, they ultimately bake. And so I worry about that. So I'm interested in the question of whatever framing materials we pick, long-term recyclability or long-term repairability. The glass could last 150 years. It's the frames that are going to die before that.
So yeah,
those things.
so we did, unfortunately, I have some bad news for you, that we had a product line that we carried that I was using and recommending for high UV exposure Southwest, and it was our aluminum clad UPVC. Unfortunately, we had to drop that product line last year because our aluminum supplier is out of Ukraine. So it got tied into the entire thing. And this has happened to a lot of European suppliers. There was a lot of supply for our componentry. And so we no longer can do aluminum clad UPVC, which would be the best of both worlds. So the other thing is, again, I want to differentiate vinyl versus UPVC. And the reason we call it UPVC is it's unplasticized, which means it's rigid vinyl. Traditional US windows are not. They're flexible vinyl. So there's a lot more expansion and contraction with the sun and the heating and cooling. UPVC windows are much more stable. And so therefore you can do larger units with them. There, of course, with stucco, I love to hear this. If you took a UPVC window and you put it in a stucco opening, I would take that stucco as close to the glass as possible and embed that frame in that wall and make it disappear. So the stucco took most of the brunt of that solar exposure. Now you can't do that so much with operables, but that's the kind of detailing where you can offset the frame and kind of like make it go away. And the last part is we can give you additional exterior coatings, which are heat applied films, which further protect that exposure. So the frame is actually sitting behind a highly engineered film that's meant to protect that UV exposure as well on that frame.
I think I might be able to send Zach a couple of photographs, you too, Sam, of the two houses I've got, one that's a decade old and one that's from 1989. And they're original frames and original construction. We've done nothing to change them. I think that it's pretty typical of what I see out here in Northern California. I'm wondering at some point, based on what Sam was describing, that some of the details that we see as normal might want to be encouraged to be better, like you're describing, to properly protect as much of the frame as you can. I've got openings and fixes, and there's still a huge amount of exposed plastic, just because that's the way we build windows, at least the ones on my house. So I just remember being able to repair the 150-year-old window frames because they had some dry rot and I didn't have to replace the whole darn sash or the whole darn window. And I'm worried what's going to happen in year 32 and a half when all the plastic on my house decides to go, ah! Yeah. And I will grant that I have lower grade plastic than you're describing, but that was, because that's what was available 20 something years ago.
I hope to get a house for 30 years and have that problem. Houses need maintenance, and if it's wood, of course, you're dealing with even more so the bugs and stuff.
One last thing, if I may, Zach, I put Larry Kinney's name in the chat box. I worked with Larry Kinney back in the 70s. He was really big even back then on figuring out how to get light into buildings in better ways, and he continued his research when he moved out to Colorado. Larry has since retired, but he was very passionate for about 20 or 25 years working on exterior shutters that were insulating. Their primary purpose was insulation. And he did a bunch of calculations looking at how many glazing layers made sense compared to exterior insulation and things like that. And I'm sure he would be an interesting resource for this conversation. He's really into the exterior shutters. He figured out how to build them so they would work in Colorado winters with snow and ice. So pretty clever.
Gary, if I can actually add to this and give a little bit more context on glass and why frames are the way they are out of Europe, there is so much research about the optimal gas chamber for argon and what the optimal size is for performance. Going bigger doesn't help, but going smaller also doesn't help. And so the sweet spot is like 12 to 16 millimeters. And so when you build a dual or triple glazed window with that type of spacing, you get this 1.5, 1.25 to 2 and something. And that's where the frames come in. The frames are having to support this optimal glass design. And so you see this like People ask, why do the frames have to be so big? It's like, because your triple glazed window, our glass is bigger than your frame, the other one you're comparing to, because we are optimizing the argon. There's no such thing as a thin, high performance triple argon. Argon, you have to use the higher performance gases in those cases because they're optimized for smaller spaces. So when you have xenon and like krypton, they actually like the small spaces. Unfortunately, we can't get those right now. So you're going to have to go with the bigger one. So I just want you to know that there's this chess game of performance and components and size and structure and hardware. It's like this, it's been going on for 30, 40 years over in Europe. It's so wonderful.
Somewhere around 5/8 of an inch. Sorry, I do inches.
Yeah, I do millimeters.
So you use 12 to 15, 12 to 18. What was it again?
12 to 16 for argon optimization. And you know what? Once you go below that, you might as well just do air instead of argon. And once you go above that, you're not gaining any more performance. It literally flattens out. It's really interesting to see the actual testing that's going on. I just want to say again, you don't see that type of testing in North America.
We don't. I agree.
You don't.
By the way, I did my own dual pane on-site construction in 1981 in Africa because I wanted dual pane windows. And at the time they wanted $150 a square foot and I could build it for $4 on site. So I built them on site, and guess what? I have about that 5/8 to 3/4 of an inch of airspace because that's what I could build it to.
That's great.
And I only had to, I didn't ever, what I have to, I had to go in and open up the windows and clean them out once in 40 years. I'd say that's pretty good.
Oh, so the other thing is that there are tests, and our typical argon loss is 1% per year.
Right.
It's actually per code. There's a code that says you can lose more than that, but the actual tested loss for the componentry with the butyl and the coatings around it is about 1% as tested in reality. Again, a test you'll never see done in North America.
Yeah, that's cool. It's very little, but 1% over time adds up to a big number.
It's a noble gas. It wants to get out. It wants to escape, and so 1% over time. So
yeah, I get it. Very cool. Thank you.
Yeah, sure.
Thanks, Gary. Jeff, you're up.
Gary, I can send you a metric ruler. They basically are paperweight for most builders in the U.S. But so Sam, I thought it was interesting when you talked about the manufacturing. Like, would you agree that it's like mostly a supply chain thing? Because it's what I want to add to that is I found it interesting that like a few years ago, Aluplast bought Chelsea Building Products, which is like I think one of the largest plastic extruders for windows in the country and for North American style windows. And you've got Cumberling in Alabama, and they manufacture direct in Florida, I think. And then they also are the ones who supply the profiles for Wythe. But like, I wonder if there's a trend where people are starting because of like local law 93 and just the demand. Do you think that we are going to see at the very least like a commodity product, mass market product here? Like, again, like Crystal Windows manufactures tilt turns, but like you have to order 150 and they've got to be the same size. Like, do you think it's trending that direction? Or do you think, you know, people like you and I are still kind of not early adopters, but do you think it's going to be continually like a noisy field of a lot of suppliers?
So if you go to say Germany to Bau, it's called Bau, and it's like their Home Depot. Like it's called Bau. So that's their Home Depot in Germany. If you go to a German Home Depot Bau and you go in and you look at the windows that are sitting on the floor, they have a 1 meter by 1 meter fixed triple. It's a little bit thinner on the triple, so I think the total performance is like an R8, just to use something that we don't need to translate. That window on the trade floor at the Home Depot of Germany cost $8 a square foot.
Yeah.
You do the economics in the background for that and how the hell they can actually sell it with a markup for $8 a square foot sitting on the floor and the entire production process sitting behind that. I actually don't know how anybody in North America who makes windows here is going to compete with the ability for a product at $8 a square foot at twice the performance sitting there on the showroom floor.
Yeah, I think it's why it's limited so much to luxury or bulk or commercial. Like, it's just not, I don't think it's going to come in for single family residents for a long time, if it does happen.
Some people are doing it. And in fact, there's a couple people in New Jersey who have fixed sizes. They just literally have a website. And when I can't sell somebody one or two UPVC windows, I send them to the guys in Jersey who have it in a warehouse.
Yeah. Interesting. Yeah, I hope it does happen, because I think one area that it's really prohibitive is like community housing projects are just not really, like, I've seen projects here in Troy, New York get declined because of the cost of passive house product. And like you mentioned, it shouldn't be cost prohibitive, but it was also lead times. It was unknown material, but like a builder grade high performing window would be pretty nice to see happen. You know, even if we're not the ones involved in it, it'd be nice to see more adoption like that.
Yeah, I agree. I think we're still because if you can't get the glass here and you have to ship the glass, it's easier just to put the window around the glass when you ship it than it is to like ship glass by itself.
Yeah.
That's ultimately the problem. It's
Good
easier
point.
to put a window. It's easier to wrap a window around it when you put it in the container.
Yeah, it's shipping protection at that point.
Yeah. At that point, the whole window's cheaper. So yeah.
Yeah.
All right, thanks, Jeff. So next up is Martin. I don't remember Martin, if you have your mic.
Yeah, I'm here. Can you hear me? Right.
Yes.
Okay. So I'm German. I grew up with tilt and turn windows, and I'm interested now in installing them in a condo we own. And I'm very frustrated that the center frame for tilt and turn windows, where the two sashes meet, are very wide, obscuring my view. And I don't think that competes very well, visually speaking, with your typical aluminum condo window center bar that's only 3 inches wide. And my question is basically, is there perhaps some compromise design where everything is beefy around the frame with UPVC, for instance, but thin in the middle?
Yeah, there is. It's our slim line. It's aluminum. It's higher in commercial. The glass dimensions. We have a slider. It's not passive house air tightness, but it's 28 millimeter glass to glass sliding to fixed. It sits in front of the other one. That's with a triple or double. We have a window that's a casement, and it's actually very, very thin. It's Aluprof. Aluprof is the frame supplier. Aluplast is the UVC guys, and they make really nice thin aluminum that competes with that steel idea. But again, you have to fit the hardware. You have to fit the multi-point in the actual frame. You have to have structural that connects to it. I mean, if people were asking for smaller windows that weren't so tall, then we could probably give you smaller frames that didn't need to accommodate the 8-foot heights that they're always asking for. So like we have to come up with a frame system that either caters to the dimensions that people are asking for, which is a little bit bulkier with more structure. If you were just asking for a 4-foot tall window that was 3 foot wide and wanted a thin, we could probably develop a frame that was smaller, but that's not what people ask for. They ask for big stuff. So that comes from the bulk. So if your opening is 5 foot wide and you want to put a 3 foot or 2 foot, or maybe it's 6 foot wide and you want to put a 3 and 3 and you want to do 7 foot tall, what is really the impact of having like a 4.5 or 5.25 inch frame? It's still, we do very big units, so they kind of disappear in like relationships. So I would say, send me what you're trying to do, and I'll literally send you the sections from the different supply lines that we have, product lines, to give you like that glass to glass for that operable casement tilt turn to fixed. I have them all. It's all lined up. So thanks for the question, Martin.
Thanks, Martin. Okay, so next is Chie Kawahara. So Chie, your question may have been answered in chat, but I wanted to give you the chance to ask it if you would like to do so.
Yeah, sure. Thank you, Zach. So UPVC, will it melt in a wildfire? And this is coming from an experience that my boss had visiting one of the burn sites from a wildfire that we had 2 years ago in this area, and saw that the regular vinyl windows, I think they were Milgard, they were just totally warped, whereas a fiberglass Marvin held its shape. So in a wildfire, how would a UPVC perform?
So UPVC is a thermoplastic. They actually use heat to form it. And so when it hits its soft point, it just goes soft. It doesn't perform, to be perfectly honest, unless you put a sprinkler on it, which they do in larger buildings. They actually sprinkler those windows because of fire code. So Fiberglass, of course, is a much better thermal structural. It's not a thermoplastic. It's a resin. So they're just two different materials.
Great. Thanks, Jay. Okay, next up is Michael Lind, and I believe that Michael, you do not have a microphone. So if I'm wrong, just interrupt me. But I'm going to ask the question, and that's if Sam, could you talk about the multi-reflections ghosting in triple glazed windows?
The triple reflection versus the dual reflection and the chatter that you see. Yeah, that's actually, it's just all windows have, I think this is the question, all windows have a reflection. And so when you look at it, you see either one or two reflections in single or double. With the three, you're going to see actually an offset. It's going to be a triple reflection. So it has like a, I want to say a chatter look to it. I actually would also like to point out that I have a 17-year-old daughter who doesn't care about windows at all, but she's mad at me. She says this regularly, that she wished she never knew that I had taught her to look at the reflection of a building to see what quality of glass they're using. And so now when she walks around like big cities, she can see the waviness of skyscrapers. And then she walks up and she says, oh, they use European glass because it's flat and like just perfectly, and the reflections are beautiful, and she can see the clouds going across. And then the next building's all like bubbly and like orby and stuff like that. So the 2 points are, is it flat? Is it overpressurized with the gas so it's owing out or in? And then, you know, how many pieces of glass are, so you can see the chatter reflection of the 3 different levels.
The curse of the connoisseur.
Curse of the connoisseur. It's like,
so
I can't just look at architecture anymore. I have to think about glass.
I want to share with you, you're getting some great comments. Buck Moorhead saying, Sam is such an incredible, iconic resource. Paige Thomas saying, thank you, Sam. This has been a very illuminating conversation. There are many others as well that I'm that are in the thread. So just really great feedback. Sam, thank you so much for everything. As we're now past an hour and a half with this, and still have 90 people on the call. I just want to put the call out right now that I think we've gotten through all the questions. But if there's another one, please go ahead and pose it in chat, and we'll get you on. But barring that, I think that we're probably ready to close up. So I'm gonna just
can I throw something out too, Zach?
Please do.
If you guys want any other content and you think we could probably give some illumination to it, throw it at Zach, and he'll ask us if we can develop some more content for you. And we'll even pull in some other people. I see Patrick Mazzilla on here. He's a fabulous, intelligent window guy. We do it as a team. We're all on the same like end zone. We're on the same, like, we don't operate independently. We're all like, we care about the same stuff. So maybe we'll pull a couple other window guys in, and we'll all have like a little chat about our same perspective on these same questions. So.
Yeah, awesome, definitely. Absolutely, please do throw ideas my way, and we'll get them. So it looks like we have a couple of more questions. So one from Kyra, and then we also have a raised hand from Chris. So we'll do Kyra first, and then Chris, we'll get to you.
Hey, I just had a question about Chinese glass versus European glass. Is there a big difference in the standards, or is there a reason to use European over Chinese?
I won't categorize them quite by countries. I'll categorize them by the quality of the product that comes out of each factory. There is high quality glass in China. There's also low quality glass in Europe. So.
True. Okay, is there an easy way of telling, I guess?
There's not. I don't buy or deal in Chinese windows, but I do know that there are lots of factories being set up that are completely German machined and to the standards and processes in order to execute those high quality architectural products in China. I don't know that they're exporting to the US. I haven't seen them yet.
Yeah, there's one passive house window manufacturer in Canada that's using Chinese glass, which is why I was curious.
Yeah, so there's a funny little thing. When the World Trade Center in New York City was being built, they wanted to source America. And they wanted the entire facade to be in steel. They wanted it all to be sourced American. Unfortunately, only the first 6 floors are American glass because of the blast-proof shatter aspect of the, like, you know, they didn't want a truck to blow. The rest of the skyscraper is Chinese. They couldn't even find the glass in North America. So It's just the reality of the economics of the situation.
Thank you.
Yep.
Cool. And sorry for I'm chatting people as you're going, and sometimes I forget to mute. So sorry for all the clatter over here on my end. So Chris, you're up next.
Hey, buddy. How you doing, Sam?
Good, man. Where you been?
I'm telling you. So I got some questions for you. Like when
I
you
know
were
you
at when you were at 475, you were like pushing the envelope on basically everything. So you were looking at ERVs and HRVs and the frames of the windows and kind of magic boxes and the frames of the windows and stuff like that. And then you were also like pretty phenomenal at spreadsheets and figuring out like ways of kind of monetizing the installation of windows and, you know, kind of getting pockets of money like investment tax credits and solar this, like, you know, so instead of doing a window installation, you're actually doing a solar install and it just happens to be expressed as glass or windows. Can you talk about like what Zola is doing in that kind of like in that space that you were pushing into in the ERVs, HRVs, magic boxes, financing of windows and stuff like that under different programs? Because like if you just replace a window, you're just replacing a window. But if you're installing solar and it happens to be a window, then it changes the financing completely.
Yeah. So I just want to say I'm really looking forward to going back to BAU Munich in January of this coming year. It's going to be back in person. It's in Munich. It's going to be, it has in the past been 180,000 people in 7 days. And it's like 17 football fields of high performance, robotic, the best, the advancements, the architectural. It's like a crazy, that's where I get so much knowledge from those types of trade shows. I'm going in January to BAU Munich again. The landscape, since, by the way, Chris, we've known each other for over a decade. It's so good to see you, man. The landscape has changed so much. I was in Batamat just before COVID hit in the end of 2019, December. Batamat is a huge trade show in Paris. And I was seeing mechanical systems that were crazy. This whole idea of magic box is gone. Instead, it was a single exterior heat pump compressor that was servicing with heat recovery all of the heating, cooling, hot water needs, as well as storage with pre-temper. And they were so small and they were for residential and they were run by solar panels. It's like net zero looks different in Europe right now. It's combined systems that utilize the resources. How windows fit into that, it has to do with ventilation. So the one thing they didn't do is make up ventilation and have central heat recovery systems. There is a ton of product that is coming through and has been developed for micro ventilation systems that can be window coupled. So by installing your window, you're installing your makeup air with heat recovery system as part of your window. And then you're installing these central, very micro, tiny little combined systems that utilizes all the best energy footprint that's solar run. And then you're putting in an amazing shell and you have the lowest cost footprint to execute the highest performance structure. That's what's happening right now in Europe. I can't wait to go back in January and get an update and see what they've come up with next and what the next iteration is.
Gotcha. And in Zola, Zola is pushing into like, you know, you're going to be expressing that in Zola products going forward in the future. Is that kind of the plan and the thought?
Well, if we can couple some stuff without doing major modifications to the product realms, then maybe we might integrate some of this stuff. I mean, we definitely do some trickle vents. We do some high performance trickle vents. I've even seen some like trickle systems that are part of the glazing assembly and not even in the frame, which is kind of interesting. It actually comes with part of the glass and gets installed into glazing. There's some, I actually, in Asia, you see a lot of times that they actually make the heat pump, just a standard heat pump. They make it part of the fenestration system. What does that mean? They literally, a window over a louvered grill and then a box and the heat pump's in the box circulating through the louvered grill, and it's actually all the water tightness is part of the window. So there's potentials for lots of that. We don't have anything on the docket to push any of this. I think where the really interesting thing is in the component stuff, there are glass suppliers who are doing phase changing glass that's actually opaque. What does that mean? It means it's two pieces of glass with an aerogel wall in it and a louver at the top and a louver at the bottom that can open and close and allow or shut down circulation, turning it from a 0 U value to a U value of 20. Like it's like crazy what it can do. So when it's heating and it wants to give off its heat at night, it circulates. And when during the day it wants to shut it down, it closes and becomes a thermal. But that's a fenestration product. That's not a construction product. So it's going to be interesting to see what products come through that have ventilation and or thermal properties that are both opaque and also transparent, that are going to be integrated into the fenestration layer versus like a wholly separate construction product. So there's actually a whole series of products that are just going to go in an aluminum frame, be installed with your windows. And that's kind of the potential. I'm really excited about that kind of stuff. So thanks for the question, Chris. That was awesome.
Thanks, Chris. So following up on Michael Lynn's question about the ghosting, he specifically, and I missed this, he was specifically wondering if there's a difference between European glass and North American glass or windows in terms of that issue.
And when he means ghosting, he means leakage that causes moisture condensation on the inside?
No, I think he's talking about the reflection, the multiple reflections. Is there a difference?
There is a slight difference, and it has to do with the coatings that they apply. The windows in Europe, or that come out of Europe, seem to be much shinier and much more reflective because of the quality of like literally the layer that they're sticking into the window. But it also is the windows are clearer and have less green or brownish color. So the windows that you are seeing coming out of the glass that typically you see in North America is really a legacy system of the 1980s energy, for San Antonio, Texas. Those coatings are kind of like the old coatings that have a color to them, like almost a copperish tone to it. Those coatings are not what's being used in Europe. So it is shinier. You're going to get more reflections. I want to throw out, we can deal in Ornolux glass if you have a bird problem. We can source it, we can get it, it can go in, because as the window gets shinier, there's a Silicon Valley HBO show with the guy who bought the car, and he had this house, and they're talking, and crows kept falling because they kept running into his window and dying around them as they're having conversation. If they have shiny windows, you need to do something about it. Yeah.
Great, thank you. Okay, we have a question from Ben McDonald, and I think we probably need to wrap up the show once we've gotten this one. But this should be interesting. So, Ben, are you available to ask your question?
Hey guys, yeah, thanks for this. This is fantastic. Just to read my question: is it reasonable to be paranoid about IGU fail rates in general, and potentially think about going to multiple single pane units to avoid that fear? And I'm just sort of curious where warranties stand in relation to actual sort of expected lifespan of IGUs, whether they're double or triple paned.
Yeah, so I'd mentioned earlier that there's testing about the componentry used for creating the glazing assemblies, and there's about a 1% loss of argon gas per year. That means that the windows are very tight. A lot of the fail rate you see in glazing has to do with the fact that they just separate, and when they heat and cool and the pressure, they're just sucking air in and out, and then they just start to like ghost on the inside and fail, and just like that's what you never want. If that happens in a European glazing assembly, you're going to get a replacement piece of glass shipped. The window itself is a component-based system. So all you're going to do is pop out the stops, take the old glass out, put the new glass in, make sure the spacers are in, put the stops back in. You're not going to have, it's not going to be like a huge ordeal, unless it's like a landmark window where everything's like nicely caulked in, and it might be a little bit different. But I don't think there should be any fear when it comes to that. I think you should just be dealing with somebody who's going to sell you a quality piece of glass. And what you're really referring to is dealing with people who are not selling you quality windows. And that's the difference you're really dealing with there. So. And
what lifespan do you have in your mind? Like a 30-year lifespan?
You're talking about warranty or lifespan?
Yeah.
Warranty is never going to be 30 years, not unless you. Yeah. I mean, the window manufacturers and stuff like that have been around, some of them for more than 60 years. So we're talking about deep experience with this stuff. I mean, it's not the factories themselves and where the stuff is made. Now, the life expectancy, yeah, glass should be up there, definitely. I think the gaskets are going to be the first thing that fails and need to be replaced because they're going to get soft. It's a fully adjustable hardware window, so unless it's misinstalled or abused, that hardware should actually also, and the frame should actually also last. The two things that you're going to need to be worried most about is exterior caulk to keep the watertight, whatever that connection is, the watertight connection, so it's draining outward. And then the gaskets, and then third is going to be glass.
So you're least worried about the spacer bar adhesive connection that actually makes up the IGU. You're
For the windows we sell, I'm not worried about it. The windows I might buy locally where I live, yeah, but for the windows we sell, no. I know the componentry. The beautiful thing is if you're worried about it, I'll send you the spec for that component that's used in that glazing. I'll share with you so you're fully transparent and you get it too. And you'll see why I'm not worried about it. So we're not interested in just telling, yeah, don't worry about it, just trust us. No, we'll show it to you. We deal in high performance construction where it's full transparency. So
if I can support Sam here real quick, the good news about IGU failures is we've been in business for 19 years. All IGU failures show up in the first 3 years of the window being in. Typically, if you have a failure in the way process, material, something like that, doesn't show up like in year 7 or 8. It shows up almost right away. Very often it's actually trapped moisture that's in the glass to begin with, meaning it actually got sealed inside and you see like a tiny little crystal in the glass, like on a minus 10-degree day. But most issues with glass show up within that very short European warranty period, right? And so I think we've done 0 IGU glass replacements in years like 6 to 19, right? So hopefully that's comforting.
Second that experience too. Thanks, Patrick. Seriously, it's almost like something we rarely talk about.
All righty, Sam. Thank you so much for this. I mean, it's been really fantastic, and I think I need to mute somebody. We're getting some echo, but. There are a couple more questions. We need to actually close up the call, and I've invited folks to email you with their remaining questions. Or I know a couple of folks, but this is I think that you've broken the record for the component spotlight duration, so congratulations on that. And really, everyone, thank you so much for being here. This is a really great conversation. I think we all really appreciated Sam's expertise and breadth of experience today. And thanks again to Zola for Zola Windows support of the Accelerator. And happy Monday, everybody. We'll see you soon.
Thanks, everyone.
All right. Take care.